So I'm Cloverley Lawrence. I work for SANParks. I'm based in the Garden Route, doing work in MPAs in this area and particularly within the ADO MPA. I'm going to talk to you a little bit about the challenges and opportunities in navigating science for the sustainable decision making and using the case of the African penguin. Now, the previous speakers have provided quite a nice background to what I'm about to share. And just to contextualize some of these ideas, it's sharing a quote here. Within the next decade, the goal, particularly of ocean science in action, is to provide food, clean energy, water, medical services, and decent living conditions for all people on Earth in a sustainable way, and without overstepping the carrying capacity of the planet. However, few believe this can be done without harvesting more from the ocean and increasing activity at sea. While we know and we understand that the ocean and its ecosystem services are under threat from things like pollution, overharvesting, and of course the looming climate change. And as has been, and since this is quite a important goal for many countries, including South Africa, we have the Operation Phakisa program. Excuse me. Which aims to unlock the economic potential of the oceans and coasts, among various other projects. Within the marine environment, 7 areas were identified in which access, be it through services, goods and services of the ocean, can be leveraged to help improve the living conditions of people within South Africa. However, much of this, what underpins much of this, and to be able to achieve much of this, is the science. And that is where things, the various components of marine science plays a crucial role in how those decisions are informed and how we can take forward these objectives and be able to achieve them. So baseline information on oceanography, marine biology, biogeochemistry, and all that we understand that can inform some of these are quite important. The need for transdisciplinary and sustainability science to address this has become quite important. In recent years, the oceans and seas have received prominence, as we know, on many international agendas. To secure a safe planet and priority is the management of the ocean as a common good for humanity. And this requires smarter observations and to be able to assess the state of oceans and predict how it may change in the future. You know, the ocean is a 3-dimensional space that needs to be managed over time, which then makes it 4-dimensional. And for that, you know, we need management conservation practices that integrate the structure and function of ecosystems within these 4 dimensions. And therefore, a deeper understanding of the spatial temporal interplay is required between the physics, the chemistry, and the biology. And of course, overlaying on that is climate change, pollution, overfishing, and the resilience of the ocean to be able to remain sustainable to meet the requirements of various international agendas. So we need to be able to predict and better understand interactions as well as tipping points. And therefore, this integration between different spheres, different disciplines, but also various government institutions is required. And an improved science base is needed to help predict and minimize the impact of extreme events. And of course, new technologies will play a crucial role in how we analyze and understand and improve our understanding through the data, through modeling approaches, and various observations to help improve our understanding, but also our decision making. So I want to take you through a case study of the African penguin, where a lot of data and a lot of understanding over many, many decades by many institutions, often collaboratively, have helped decision making, but also we're still challenged despite the amount of data and information we have at hand. So, for those who don't, who may not know, this is the African penguin. It is the only endemic penguin in South Africa and Namibia. Unfortunately, it was listed as endangered in 2010, but it's been declining over several decades, and we're looking at a 68% decline even after the endangered rating in South Africa. And unfortunately, its trajectory continues to decline. So historically, we used to have up to 3 million penguins in the early 20th century. By 1956, we had 300,000 breeding pairs. And the recent count of 2023 has left us with less than 10,000 breeding pairs in the wild. So we've had a 97% decline in over 67 years. And current trajectories tell us that we're probably going to continued decline will lead to functional extinction in the wild. So this has been very concerning, as you can imagine, and over years, many institutions, scientists, and conservation bodies have come together to try and understand what has occurred, what leads to these declines, and how better to manage and mitigate these populations. So historically, up till the 16th century, penguins were being harvested by sailors mostly. Their eggs were collected, their fat was collected, and basically they were quite an easy access because they were pretty much on mainlands. They were within the countries of South Africa and Namibia, unlike other penguins that are further in the Antarctica and a bit more remote and not as accessible. And then come mid-19th century, there was this huge move and drive to harvest guano, which was used for fertilizer. So over 150 years, 200,000 tons of guano were removed from islands around South Africa. And this resulted in penguin numbers declining by 90% in the 20th century. Now, guano is quite important because penguins actually burrow into it. Once it's hardened, it's actually quite porous, and it provides a shelter from the elements, from storms, and even a cooler nesting structure compared to others. And it obviously provides protection from predation. So this was a major impact on the population as that was removed. But as you can imagine, it has compounding effects. With this meant breeding was hampered, and you've had knock-on effects on the populations. So those were some of the earlier historical impacts on penguins. However, current impacts and threats to them include predation by land as well as sea animals, things like sharks and seals in the water. There's definitely environmental stress, given that their more preferred burrowing habitat isn't available. So often there's a overheating element, otherwise a flooding component. And this also lack of adequate infrastructure leads to exposure to elements and predators. They're highly susceptible to oil spills and pollution that has had catastrophic impacts on their populations and reduces their survival rates. More recently, we're seeing emerging impacts with the introduction of ship-to-ship bunkering in Algoa Bay. We've seen an incredible decline of the Algoa Bay population just in the last 5 or 6 years with the introduction of this industry. There is a strong correlation, either the physical disturbance from the increased shipping vessels or with the noise, and there's research now to try and unravel that. What could those mechanisms be? Penguins are susceptible to disease, and also, and driving an underlying factor has been the loss of their main prey species. So they predominantly feed on small pelagic fish, and with the decline in those stocks, we've seen a subsequent decline in the penguin numbers. So of South Africa, African penguins had declined by 75% over the last 20 years, which coincided with the decrease in their main prey, which is sardine and anchovy. So these are the preferred prey. However, they're able to take other small pelagic fish if available. But we've seen the strong link with the lack of an abundance of these prey species. And this is not just problematic for African penguins. We've seen other seabird species now endangered, showing a strong influence on the lack of food based on their distribution, abundance, their condition, their foraging parameters. So we're seeing a knock-on effect in the seabird population based on the importance of these pelagic resources. As you might understand, these are important elements, trophic elements in the trophic food chain that feed marine food webs, that many different predators rely on them for food. To give you an example, in Namibia, the crash of their sardine population particularly has resulted in a crash in their penguin numbers, as you can imagine. And a few decades later, that even with the cessation of the fishing industry there, the populations have not recovered. So that ecosystem has shifted, and a huge baseline component that feeds that ecosystem has been removed, has been lacking, and it has been attributed to overfishing, just a lack of understanding of the stock at the time, as well as then oversubscription of quotas. South Africa has unfortunately gone down a similar route, but our populations of sardine and anchovy are a bit more widespread and has traveled a lot more along the coast, so it's a bit more distributed. However, the recovery has been slow, despite a reduction in fishing. So to give you an idea, with the penguins, we have the life cycle that what's indicated is how important the fish or abundant, good quality prey is needed at various stages of the life cycle. So penguins are fishing to feed themselves as well as their chicks, and they're important, particularly during the pre-molt stage, where they then go into a molting phase where they do not go to sea for almost 3 weeks, and they need adequate fat reserves to be able to sustain themselves and survive that. They then go into a breeding period, but they also need sufficient food resources to be in the best condition to go into breeding. So these various life stages can tell you the importance of good quality fish, particularly around the penguin colonies. Penguins are also restricted to feeding around their colonies just because they need to travel back to nourish their chicks. So they have a very restricted range of where they can feed. Chicks that are malnourished or lead to a stunted growth, and malnourished chicks or stunted growth also lead to stunted breeding cycles and perhaps even impacts on survival rates, particularly around predation. So given all of this information and all of this data that provided some evidence for the need for changes in policy and decision making around the penguins, there was considered the evidence was considered insufficient in establishing the strong link between the extraction of these prey species fish as well as the decline of the penguins. So an experiment was set up in 2008, collaboratively designed with the fishing industry and fisheries experts and scientists, as well as seabird experts, to look at the impacts of fishing on four penguin colonies, 2 on the west coast and 2 on the east coast or southeast coast, And here, these colonies were alternated every 3 years to be opened to fishing and to close to fishing around a 20-kilometer radius. And during that time, chick survival, body condition, as well as their population growth rate was measured as the indicator that wanted to show the impact of fishing. So this was carried out over 11 years on this 3-year cycle of open and closed. It was by no means perfect. There were many flaws. The design wasn't optimal and didn't actually reflect the penguin life history stages, and even some of the parameters measured were lacking, were not adequate. But given all of these restrictions, all of these inadequacies, there was some evidence that it benefited. The closure of fisheries benefited, and early research had come out to say there was a decrease in energy expended, particularly by breeding penguins, because they didn't have to forage very further away. There was fish available much closer to their colonies. Overall, a 1% increase in chick survival and increased breeding success was shown, particularly in certain colonies, and there was an overall increase in chick condition in some versus the other. However, the model didn't consider compounding effects and the cumulative effects of increases in other parameters. So single species modeling expertise was definitely needed that considers the biology of the species a lot more. However, these results were contested, they were disputed by the fishery scientists and the industry, and of course they raised concerns around the flaws of the experimental design. But all of that was then taken through the published literature, and various other modeling was done to try and unravel what the exact findings were. However, the rate of population decline in these colonies within this experiment had slowed by 10 to 20%. So, despite the flaws in the experiment, there was a positive effect of closure. Now, how do we navigate this science to inform decision making around the African penguins? This was considered adequate as evidence to say it is important to close areas around the penguin colonies to fishing, and much longer than just 3 years, because we needed to take in the entire life cycle. And recommendations were then made to the environmental minister to pursue this longer term closure, and particularly around the last remaining penguin colonies. And of course, there needed to be then compromise between ensuring the penguins not going extinct, but also the potential economic impacts of the closure of the small pelagic fishing industry, the restriction, should I say, on these areas that they would be excluded from. The minister overall supported these closures and called for further negotiations around the exact boundaries and the extent. That included wider stakeholder engagements, a synthesis of all the science, which by then became a bit confusing, and to make sense of the exact findings and what the disputes were. She had her CAF group deliberate over this, and finally the appointment of an international panel review of 4 experts, fisheries and seabird, and then their resulting reports and recommendations. So many years, lots of thinking, lots of collaborations, and lots of understanding and unpacking the science to be able to inform decision making. Currently, the minister has agreed on the current closure regime. However, it needs to correspond with the foraging areas that the penguins most often use. And so some negotiations around that are underway. So the challenges in achieving the sustainable in achieving sustainable outcomes, particularly for penguins, is balancing multiple uses with various impacts, understanding the species, their biology, their changing patterns, which are also changing as a small pelagic fish stock change, as well as climate change impacts that might affect various other ocean parameters. And these need to be taken into consideration. A decision made now for what we understand now and we commit to it for 10 years may then look quite different as these changes occur further down the line. So some adaptability is needed. Then we have conflicts between the economic drivers as well as other protection goals. But overall, management requires a constant engagement with stakeholders at multiple levels of government and the importance of marine spatial planning, which is, of course, challenging to implement. So it's not easy even when the science is available and when it is the best available science to then implement difficult decisions and to be able to balance ecological or conservation needs, species protection, as well as economic needs and the needs for growing the economy, which is quite important in South Africa. So there's no easy way forward, but definitely continued collaboration, knowledge sharing, co-learning, both internationally and nationally, through partnerships, addressing common challenges. I think that goes a long way. Emerging technologies contribute to advancements in ocean science, and a lot of it contributes to improving our understanding, especially around penguin movements, for example, or environmental changes in the fish stocks. We have innovation, including the use of AI, which is improving our ability to gather and interpret data. And then, of course, the ongoing engagement and dialogue to reach understanding and consensus, I think it underpins all of this. So the science is important, but the application, the interpretation is also quite important, and that needs constant engagement around.